This is a interesting and a simple question taken from an exam. In the circuit below, the question is what should be the range of capacitance value C for which the circuit would be underdamped. Now you see there is nothing given, no switching, no initial values, no nothing. The question is the circuit has to be underdamped. So if we remember, for an underdamped circuit, alpha used to be less than omega 0. And for a parallel RLC circuit, you see here there are two inductances. So we can solve their parallel equivalent and can be replaced by one inductance. And all these resistances can be solved to get a circuit with one inductance, which will be 10 Henry in parallel with 5 Henry, and one resistance and one capacitance C. So the C is a resistance that is the parallel combination of 800 and 600 and 150 plus 250, and an inductance that is 10 Henry in parallel with 5 Henry. So once you solve for this, we know that we are dealing with a parallel RLC circuit. So this is going to be equal to 1 by 800 plus 1 by 600 plus 1 by 400. The reciprocal of this thing is going to be the R, and similarly the L is going to be 1 over 1 over 10 plus 1 over 5, or we can use the product rule, which can be computed from here as well. 10 into 5 over 10 plus 5, product over sum. So here 50 over 15 Henries. So here we are going to get something similar. So let me compute this for you. So 1 divided by 800, 1 divided by 800 plus 1 divided by 600 plus 1 divided by 400 is equal to, is going to give me the denominator term, and 1 divided by answer is going to give me 2400 over 13, which actually is 184.6. For simplicity, let me write, okay, let me keep it 184.6, because although I can take it as 185 without losing much of the generality of the question. 50 over 15 is 3.333. We cannot do much of for this. Don't take it as 3. So with this situation, now we are facing this inequality, where alpha is equal to 1 over 2 RC, and this should be less than 1 over square root of LC. So if we take the square, we are going to get 1 over 4 R square C square should be less than 1 over LC. So taking the square basically does not change anything in the inequality. However, now we can say that 4R square C square should be greater than LC. When we take the reciprocal of both sides, the inequality flips, because if 1 over 3 is less than 1 over 2, then 3 is greater than 2. So here we are going to get C square over C is greater than L over 4R square, or C should be greater than L over 4R square. So for exactly these values, these range of values, the circuit will be underdamped. It's so simple, and we can find that. So while this is an inequality here, we are going to put equality sign here, means this thing is equal to L in this case is 3.33 divided by 4 into 184.6 square, which is equal to divided by 4 divided by 184.6 square is equal to 2.445 or 2.45 into 10 raised to the power minus 5 farad. So C should be greater than 2.45 into 10 raised to the power minus 5 farad, or C should be greater than 24.5 into 10 raised to the power minus 6 farad, or C should be greater than 24.5 microfarad. So if you use any capacitance in this circuit that has a value greater than 24.5 microfarad, for all other things same, the circuit is going to be underdamped.